Question 3. This question is about 2-methyl butyl. Name the mechanism for reaction of 2-methyl butyl with concentrated sulfuric acid. It's going to be actually going to be a very nice mechanism. Yeah, from year 1. But they just put a not so nice compound that's reacts with it, so it trigs you up. But it's actually electrophilic addition. And you know, an A-level chemistry paper 2 doesn't just test year 2 mechanism, it also tests year 1 mechanism. Obviously they're going to be harder than your average textbook questions, but it's still going to be very similar, just a slightly bit harder. So electrophilic addition. Now we need to draw this out. 2-methyl butyl. So we've got methane, ethane, propane. Actually, there's a better way of doing this. There's alkene, C double electrophilic addition, and we have C double bond C. We've got 2-methyl, we've got methyl, CH2, CH3, and we've got a hydrogen and a hydrogen. And what happens is the concentrated sulfuric acid, H partially positive, oxygen partially negative, S double bond O, OH, right? From the double bond to the hydrogen, then from the middle of the OH to the oxygen, and then what you form is with single bonds H, 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 CH3, CH2, CH3, and now this carbon's positive, right? And now this bonded to a hydrogen. Now this oxygen has a lone pair of electrons and is negative, and it also has the S double bond O, OH. Now it's going to go from the lone pair of electrons to the positive charge, and then you form what you'd really expect, just bonds to it. So it's just going to be O, S, double bond O, OH. And then there's an extra step where you warm the alcohol plus, you warm the reaction mixture plus add water, hydrolyzes to form an alcohol, and then the H2SO4 is regenerated by the end of the reaction, and therefore the H2SO4 acts as a catalyst. But that's not what it's asking. It just wants to know the mechanism for this bit, and there you go. For 5 marks, 1 mark I'm assuming for the name of the mechanism, and then 4 marks for this. So that's stage 1, from double bond to H, then middle of OH to the oxygen. That's stage this is stage 2. Now that's positive charge, oxygen has a low pair of electron negative, and then that is stage 3. 3.2, draw the structure of the minor product formed. Well, this is the major product. The minor product is just going to be whether OS double bond O double bond OH is on the first carbon instead. So it's just going to be CC CH3 CH2 CH3 H here instead of on the first carbon, instead of the second carbon on the first carbon, yeah, OS double bond O double bond O. Excuse me for the double bond O, pretty bad. Then you've got the H and the H. Now, why is this a minor product? Well, that's structure. Why is it? Because the major product major product formed via more stable carbocation. Why? Because due to positive inductive effect of how many alkyl groups. Well, if you look at the major product, it's this carbon attached to one alkyl group, CH3, attached to another alkyl group, CH2, then this CH2, CH3, so that's 3 alkyl groups. Whereas this, the minor product, this carbon is only attached to one alkyl group. So due to positive inductive effect of 3 alkyl groups compared to one alkyl group. 3.3, question 3.3, draw the skeletal formula functional group isomer of 2-methyl-butyronine. Functional group isomer. So we're going to change functional group, right? So it's going to look like a cyclic. It's going to be a cyclic structure. So 2-methyl-butyronine, well, it's got 2 methyls, so we've got methyl, bute, methane, ethane, propane, butane. So it's going to have 5 carbons, right? And it's an alkene. So it's going to have a cycloalkane. It's going to be cycloalkane. So in this case, that should be fine. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have 5 carbons and your hydrogen. Cycloalkane. And then it says 2-methyl-butyronine can form a polymer. State the type of polymerization. It's going to be addition polymerization. Addition polymerization. And then it says for 1 mark, draw the repeating unit for the polymer formed. So 1 mark for the type of polymerization, 1 mark for the repeating unit for the polymer formed. Well, we know that we have CH3, CH3, CH2, CH3, right? So that's all it's going to be. That's all it's going to be. But just the key details that obviously you need these points sticking out. You're going to have a hydrogen here, a hydrogen here. What's left? Hydrogen here, hydrogen here. We've got CH3. We've got a CH2 and a CH3. Oh, well, it's not this. It's not this structure. It's going to be this one, right? Because that's with an extra hydrogen. So CH2, CH2, CH3, CH2, CH3. CH3. We could show the individual hydrogen bond, but we could just say, I'm pretty sure, CH2 and then CH3. Well, actually, maybe once to go like this, CH2, CH3. Okay, and that is the end of question 3. And make sure you show these points sticking out. And that's the end of question 3.